the topic is related to the motorcycle battery management system, where we are all about talking the safety, what battery safety is there, and what needs to be compliance with respect to that. And as per the suppliers are always thinking how I can comply with that battery, because OEMs, sometimes the OEMs don't know about what exactly they want to integrate or implement in their design, because little bit the not an awareness about the standards. But in some of the cases, these tier ones also want to implement those things, and they want to create this awareness, to bring the awareness across the all tier 1 to tier 2 and also OEMs too. Okay, the topic is for the today is safety integrity in electrical motorcycle battery management system, and how to comply ISO 26262 with respect to safety element out of context. Okay, so the agenda is to check like how the rise of electrical motorcycle in recent years. In the last 5 years, we already saw how like in very pace like the EV sales regarding a two-wheeler or also four-wheeler, it's very rises very quickly. So around it takes around 10% and 11% of stakes overall sales across the IC engines, right? So second part will go through the understanding of the ISO 26262. Then also we see challenges as per the applying ISO 26262 in the BMS development. Then we'll see ACOEC compliance, how we can streamline those ACOEC. And then we go for the little bit about the HARA analysis, how we can identify the safety requirements as per the battery management system. And then we go for the design of safety element regarding BMS and go for the conclusion parts, right? So here you can see the rise of electrical motorcycle. So like India is adapting the EV trend. In last almost 3 and 4 5 years. So you can see here around 1.3 million vehicles are sold, which are categorized in electric, right? Like we can take example like Ola, Ather, like even Bajaj, TVS also, and in four-wheeler also Tata Motors, and now recently Mahindra also is there. These are the Indian OEMs. They are bringing this EV technology across the for Indian consumers, right? But why this rise of electric motorcycle? So there are three major benefits. Like one of the economic benefits, second one environmental concerns, and third one is the technological advancements. So in economic benefits, obviously, the people are always thinking how my IC engine vehicles like maintenance cost is very high because of the some of the repairing cost, maintenance cost, right? But electric vehicle, obviously, there are no maintenance because the only battery is there, only replacement will be there, right? And the government incentive. So initially government provides some incentive based on that, like some subsidy, but recently they reduce those things, but maybe in future they can implement those things so people can benefit from that. The second one is the environmental concern. So obviously electric vehicles, so obviously zero emissions are there, and those are like environmental people. So those things like this is will be a severe condition. So they are obviously using the EVs, right? And the technological advancement, like obviously it's improve the battery technology, again range, efficiency is there. Second one is the performance, right? And third one is the features. So obviously electric vehicles comes with a lot of features. The previous one vehicles as a two-wheeler industry, so they're not thinking about the features. So recently EV vehicles, they come up with the even music system inbuilt in the vehicles. Other features like some of the two-wheeler also bringing like blind spot detection in their two-wheeler motorcycle. So these are the some of the key features like youngsters and current generation, like we can call it as a Gen Z. So they are already attracted to the electric, right? So we can just go through the overview of the electric motorcycle. So you can see here one of the example where you can see the typical motorcycle is as it is, but only the change is about the IC engine. So only we replace the starter motor and magneto, the previous one, we replace with the traction motor. And for the driving the motor, we as a power backup, so we need a battery. Okay, and to manage the battery performance, we need a battery management system. So battery management system consists of the like the sensing communication, also it's control the batteries performance, like say state of charge, state of health. So these are some primary functions and associated hazards of the battery. So here you can see the battery management system like works as a, it's estimating the charge of battery, right? It's estimating the health of battery. So it's estimating of what is the storage of energy, what exactly the percentage remains, right? Also it's balancing the sales, right? And also BMS also ensure the safety and security. So our main aspect of the safety and security, right? And what exactly the hazards can be associated with your battery, right? You can see here. So if my battery is like getting overcharged, like or overheat or undercharge, okay, or if it if any accident happens, then what will be the impact after the accident. So that can be the impact. It at the end of the impact is the thermal runaway. So that can be directly either you can meet with an accident with a fire or explosion, right? Or it can be impacting our surrounding areas always. So here you can see the typical architecture of the BMS. So its BMS consists of the acquisition of the data like battery data like current, voltage, and temperature. Also, it's having some mechanism of the safety. Also, it's sharing those data on the user interface at the instrument cluster, right? And for that, to manage those things, so we have communication modules, thermal management are there. So main features of the BMS is the cell voltage monitoring, pre-charge control, SOC calculations, SOH estimation, charge control, discharge control, cell balancing. So these are the main key feature of the BMS, right? So what exactly the importance of the BMS safety, right? So one of the thing is SOA. So when we talking about the battery, so obviously we are thinking about the safe operating area. Obviously batteries comes with the voltage, current, and temperature. One of the three key parameters, and we call it as a safe operating areas. So for this, we need to prevent battery from the violation of SOA. One thing. Second thing, to track the battery status and compute its health. Third one is your to transmit the battery information to the driver, because the driver needs to be knows about what exactly my status of the battery. Okay. Also the thermal, if it's if in case my heat is increases, then need your active cooling also or passive cooling. Whatever design needs to be as per requirement. So OEMs can thought about that what can be cooling required as a active cooling or passive cooling. If space is there, then you can put passive. But as per the obviously we need like space is very less. So mostly people are using active cooling, either they like liquid cooling or some of the using fan or whatever. Those are the needs to be implemented. Also need to equalize the cells, optimizing battery uses. So these are the main key importance of the battery safety. Because of that, if we not follow this, then this can be the consequences of the battery. So if my SOE violated, then above the range of temperature, if we be beyond 90 degrees Celsius, it can be this can be the major effects. Like till 300 degrees Celsius, it can be thermal runaway happens and battery can explode. And below the 0 degrees Celsius, the cathode breakdown short circuit can be happen, and again battery can be the it can be the damage or it can be exploded. So for that, we need to maintain the safe operating area of the battery. So come to the functional safety. So obviously, when we thought about the functional safety is your feature of the system that can detect your failure or try to mitigate if you can provide some features. So prevention and detection is the necessary of the main key definition of the safety. As a key effective safety implementation is aimed to to implement some fail-safe or fail operational scenarios. We can call it as a limp home mode or something that can OEMs or tier ones can think about that, like to provide something as a fail or fail operational scenario that can prevent the failure, and it aims to detect any failures and also inform to users. So already everyone knows about the ISO 26262 framework. So I just go through that exactly what exactly just in shorts. So ISO 26262 consists 12 parts in 2018 editions. So recently they added motorcycle parts as a part 12, and a separate part for the semiconductor application is part 11. So first part is for the definition, second part is for the management, third part is for your concept definition, where you can determine the hazards, risk associated, and SE or MC level with respect to 12 parts, right? Then system level at the part 4, where you can describe your or define your system technical safety concept and testing strategies. Then you have to define your product development as per the requirements, and then go for the design development activities. In part 6, you go for this software development. Then in part 12 is for the motorcycle safety integrity. Then part 7 is for your production operation. Part 8 is for your supporting process, where you can like we have already using change management, configuration management. These are the our quality management systems supporting processes that already is consist in part 8, right? So we categorize the ISO 262 framework, so we can see the management, development, supporting process. These are the main core of the framework, right? And this standards includes the 12 parts, almost 50 chapters, 110 work products as a deliverables, 180 plus engineering methods, and 600 plus requirements. But it is obviously complex standard to follow and to maintain, to adhere all of the things. But uh, as per the requirements, we have to determine what exactly we need to implement, what we need to exactly to meet the compliance, right? So for that, there are different methodology there in standard, like acid decomposition are there, or safety element out of context are one of the thing. So we already talk, we're going to talk about that. So what actually challenges like to apply ISO to EVs? Like one of the key challenges is the complexity of EV system. So in battery system, obviously it is a high voltage battery. The chance of the shocks are there. Again, if battery explode, then obviously there can be the hazards of the fire, right? Then integration, one of the things, the rapid changes, the continuous evolution. And one second topic is about the software updates, because all of these things are controlled by telematics, right? So definitely there are challenges with respect to cybersecurity. Then supply chain management, because OEMs or tier ones can't define everything their own, because they need integration with different their partners, like different like tier one, tier two, tier three. So everyone needs to be adhere the standards. There where the coordination again the critical, because if only OEMs follow the standard, but it needs to be followed their stakeholders as well. And again, quality. So quality is one of the key things where everyone needs to be aware that what exactly the standards needs to be implemented. And the comprehensive testing and validation. So for the electric vehicle, still we are not meeting all of these testing simulation methodology, right? Because the crash tests simulations are recently, we are like in India, recently in 2-3 years, we are exploring those things. How can we simulate battery failures, and what can be the consequences if battery fails? Then system interdependency, so complex interaction and redundancy. For if battery fails, then what can be the fail-safe technology, or can be fail-safe, fail operational technology can be implemented. So these are some challenges are need to be like everyone like as OEM or tier ones, they are trying to identify those things, and they are fulfilling if we can meet those challenges. So our exact topic is around safety element out of context. So if I want to develop the battery management system, or I want to develop any electronic ECUs or any software or hardware component, so if I don't have any requirement about the safety, then how I can adhere those things, and how I can go for the safety compliance. So in the standard, around the standard, they mentioned the one of the clause in the safety element out of constant in part 8 is around, you can go for the you can assumption basis, you can go for the requirement and go for the implementation. So safety element, what exactly safety element out of context? So it is a system or a hardware where you can assume the requirement, okay, and you can go for the implementation, but you need to follow all of the clauses as per the standard. So here is the one of the uh, key picture about what exactly system development as per the SEooC, right? So you assume the requirement, go for the development, and establish the assumption of the validity. If you meet the validity of assumption, then you go for the compliance. So what exactly is SEooC? So it's obviously assumption basis requirement, assumption from the top level system, and assumption from the external interfaces. So example, I'm assuming I'm like making battery management system. Obviously, my BMS is integrating with the traction motor controller. My BMS is integrating with the either vehicle level any control unit, or my BMS is integrating with my vehicle cluster or whatever. So these are the some external interfaces I need to be assume what exactly inputs or what exactly data will be the exchange between all of these stakeholders, right? So that requirements I need to be assumed, that for I can take a reference from the standards or take reference from the research papers, right? And we need to assume some requirement from the top level systems. Like top level system means, example, my battery management system is integrating with all of the like motor controller, or it's integrating with the battery. So that need to be taken care in my references. So for as per the clauses, you need to follow part 3, part 4, part 5, part 6, and where you can see in part 3, clause 5, 6, 7, 8 is you can consider as a partially or fully in scope as per your development. So you can either comply with as a partial compliance, or you can go for the full compliance as per your convenience. But you have to fully compliant with this respect to the part 5, part 6, where you can have only the feasibility or exemption in the part 4, where in clause 8 and clause 9, because you do not intended development as per the OEM, so you can exclude the OEM level testing as a system validation. So there you can exemption is there for the compliance. But in SEooC, you have to go for the part 3, part 4, part 5, part 6, and other supporting processes you can go for the uses. So for the understanding of the requirement, like we take as an example of the hazard identification. Okay, either we take as example as the failure of BMS, what exactly effect of failure and vehicle level hazard. So here you can check the or take as an input. So these are the three main critical failures. One of the no energy input from the battery. Second one, the over voltage or overcharge of the battery pack. And third one is a high voltage battery charging system. So that the effects is, one of the effects is the, if no energy from battery, so obviously no power output, and that will be the consequences like loss of power. So sudden deceleration or sudden loss of acceleration will happen, and that can create a hazard and create an accident, met an accident. For the over voltage, overcharge, and over current condition, so thermal runaway happen, leading to fire, and fire, because of the fire, obviously more consequences going to there. And third one is a high voltage battery system as unintended condition, then obviously high voltage exposure and electric shock will be there. So these three critical hazards are we need to consider and go for the requirement development, right? So for the BMS SEEL determination, but in motorcycle we call it as a MSEEL determination in part 12. So for that we have to identify the hazards, determine the severity as per the hazards, determine the exposure, determine the controllability, and assign SEEL and MSEEL ratings. So you can see here like assessment, then what exactly the severity, extent of harm, it's how it's going to be frequently going to happen, and then exposure and the controllability. So controllability depend on the driver controls and system level controls. So basis on that calculation, you will get a SEEL or MSEEL. So this is one of the generic example of the MSEEL determination. Here you can see the one of the example of the unintended release of heat leading to fire. If if battery explodes, then what can be the consequences as per the scenario? If battery explodes, then if one of the condition is the vehicle is driving on the highway, and at that condition severity is very high, severity is very 3, severity level is 3, that because it can be lead to driver suddenly losing the control of the vehicle, which can cause a fatal accident. The exposure is around exposure is 3, that means it can be 10% possibilities it can be happen, and the controllability is difficult to control. So as per the SEEL and MSEEL table, your product is it determined as a MSEEL-C. So for that we have to follow all MSEEL-C compliance requirement as per the all part 3, part 4, part 5, and part 6, right? So if go for the safety goal and safety concept, so this will be your safety goal and the safe state concept, concept and safety concept for that BMS. So where your safety goal will be to the avoid battery SOA violation. Your safety integrity is the MSEEL-C, and your safe state will be the open like contactor, that means disconnect battery from the vehicle, and go for the active cooling if temperature is high or any malfunction occurs. And like my safety goals, as I decompose the requirement, so my requirement will be the BMS should reasonably charge the battery and to maintain or prevent battery pack from overcharging, over current, and over temperature conditions. So if my maintains SOA, if SOA violated, then initiate warning, go for the safe state. This will be my implementation technology for the BMS, right? So as an implementation point, as a implementation with respect to standards, so as ISO 26262 provide the comprehensive clauses as per your part 3, part 4, part 5, part 6, part 7. So here you can from the item definition and has like part 3, it's partially in scope for the SEooC, but you can take a reference as for the requirement. Then go for the technical safety concept creation. From the FSC, you have to create your architecture and go for the development. And basis on your requirement, go for the hardware software development, then go for testing. And after the testing and qualification, if your product is meeting all the requirement, then go for the production and operations, right? So in the system development, so the workflow as a traceability point of view, so first you go for the determine your safety goals, then go for the requirements, then go for the technical safety requirements derivation, then go for the hardware and software specification developments, then you go for the test specification as per your requirements. And basis on that, your all of these things you can go for the compliance, right? So starts with your requirement and ends with your test reports, right? So basically it provides 3 parameters like analysis, design, and verification. So from the analysis, you will get the FMEA, FTA as a failure mode effects, fault analysis, system FMEDA, then SPFM, PA measure calculations as at per the your hardware level. Then at the design level, you get as a output as a work products, you will get the hardware software architecture, digital design, test case derivation, and at the verification and validation, you will get the QA report, validation, and compliance. So this will be your like as a system development point of view, you need to go for this complete cycle. As a one part is your traceability development and one part is your product development. So as per like we know there is problem, but something like how to mitigate those failures, right? So in standard they obviously provide some fail safe, fail operational definition, but how to go for the development or integration developments, right? So here you can see example. So the failure from the either software or hardware component, right? In hardware, that can be random or systematic, or in software, that can be systematic failure. So that failure, uh, like if that failure occurs, then it lead to be my component will be in incorrect states, right? And then that incorrect state will be to go for the failure of that system. So here you can see example at the hardware level. If any fault occurs, then my hardware system will fails, right? And then if my hardware fails, then it can be fails my system. If system fails, then it fails my vehicle. But how to mitigate those things, right? At the first level, at fourth level, we have to follow all the quality checks at your design level. So we can prevent the fault to follow guidelines and processes, right? At the second thing, you have to detect the faults. For detection, you have to design reviews, code analysis, and testings, right? And if failure occurs, then you have to provide some fault tolerance, like in redundant design, protection provision needs to be implemented in your design. And if still failure is persist, then you have to provide robustness, either redundant either shut off or warning, or provide some fail safe or fail operational scenarios in your vehicle. So for that, there are some methods, FMD, FTA, DFA are there. So using this, like some methodology of testing on the analysis part, you can mitigating either like you are mitigating, not overall mitigating, but at least you reduce your failures and reduce your possible errors or hazards. So for the model-based approach, as ANSYS Medini can provide solution for that. So here, like you can determine the requirement, you can determine the, like architecture or model, you can determine your fault analysis, FMDA, and then go for the analysis for all design development activities, right? So test categories for the product compliance. So you have three types of like hardware software integration, then you have system level testing, and then vehicle level testing is there. So these are the key test requirements need to be follow and implement. So for vehicle level testing, obviously it's in partially scope in SEooC, because obviously we are developing SEooC system, not in any OEM specific, but we are developing our product as per their functional specific. So if any OEM permits, then we can test our product at that vehicle, or we can internally we can test at our end only. But for that, these test requirements are need to be follow and need to be we have to comply, right? Okay, sorry. And for safety validation, so these are the inputs from the requirement point of view, right? And then you have to go for the test plan, then you go for the strategy definition, and basis on that, you go for the validation. So once you follow all of these stages, then you can qualify your product as a safety compliant, right? From the starting from the requirements, from the deriving the test cases, validate those test cases with respect to the standard and compliance, and go for the quality assurance checks. Based on that, you can comply your product as a safety compliant, right? As a conclusion point of view, so if you follow the SEooC approach, then obviously we can reuse our component at different OEMs level, because then we don't have to repeat those activities again and again, because we already consider most of the requirements from the initial levels, and then go for implementations. So only we have to maybe some few requirements can need to be accommodated, and then go for the implementation. So that can save our time. Second, flexibility and scalability. So it's allow flexible integration across the vehicles. Then efficient safety certification and compliance, because we already go for all of the checks. Then that can be helps us to implement those things in easily for different OEMs. So that can helps us to as a provide compliance and certification. And the like assumption of use. So we already assume some requirements, so that can be the helpful for the developments, right? So the basic the presentation idea is how to SEooC can help to develop any product. But here I already use the example of the BMS. So we assume the requirements, go for the acid determination or MC determination, and from those requirements we can define the concept and go for the development. And at the development end, what the test cases can be you have to perform, that you have to go and need to be comply with those requirements. So at the like already we are like everyone talks about safety and security, and we follow all of these things, but the implementation is one of the things. But to follow those standard and compliance is not only scope of the OEMs or suppliers, it's also enhanced with the peoples as well, the users as well, because standards are there, but its uses and it depends on the users, because misuses can happen, misuses in the high like levels. So we can meet standards and we can design and develop everything as per the requirement, but at the end users can spoil the features, right? So thank you.